Hi everyone, and welcome back for round 2 of the Algebra 1B first semester exam review. This is the second review packet that covers chapters 5 and 6, and this video will cover the first page, which is problems 1 through 4. I'm going to get started with problem number 1, which is asking you to solve a system. Now problems 1 and 2 are very similar, and remember that whenever you're asked to solve a system, you could use either substitution or elimination. Now, sometimes one is a little bit easier than the other, but both will always work. So it's up to you. Whichever one you feel like using is perfectly fine. I think that I will do number 1 with substitution and number 2 with elimination, just so you can see the differences between the two and how to use each method. Okay, so the first problem I'm going to use elimination for. Remember when I'm looking for a solution to a system, I'm looking for a coordinate, and that coordinate represents the place that these two lines would cross if I were to graph them. Okay? So I'm going to start by noticing here that I have y all by itself here, which is exactly what you want to start substitution. Now that I have y by itself, I can say y equals this whole chunk over here. So y equals 2x minus 3. And I'm going to take that 2x minus 3 and put it in place of y in the other equation. Okay? Here's what that will end up looking like. I will end up with 2x minus 3 equal to x plus 1. Okay? So I took what y equaled from the first equation, and I put it in place of y in the second equation. Now I'm just going to solve for x, so I will subtract 1x from each side. Remember, 2x minus x is 1x. Okay, it's not just 2. This is like 2x minus 1x, and so you'd be left with 1x left over. Minus 3 equals 1. Once again, I'm going to move over here. From here, I would add 3 to both sides. So then I would end up with x equal to positive 4. Okay? That's half of my answer. Remember, I need to find an x coordinate and a y coordinate. So now I know what x would equal. So now I'm going to take that 4 and plug it back into either one of the original equations. And you really can use either one you want, whichever one you think looks easier. I think this second one looks pretty easy. Y equals x plus 1. So I'm going to put that 4 in place of the x. So y would equal 4 plus 1, which is 5. And that means that your coordinate, or your solution, would be 4, 5. Okay. Now the second problem could be solved exactly the same way. But I said that I would do the first one with substitution and the second one with elimination. So here's what elimination looks like. To start elimination off correctly, you want to make sure that your y's and your x's are all lined up. And here they are. You've got y on top of y, equal on top of equal, x on top of x, number on top of number. That's exactly what you want. Now we need to pick something that would help us cancel out one of those variables. These y's match up pretty nicely, but in order for them to cancel out, I need one of them to be negative. So I'm going to take this bottom equation and make the y negative. However, if I do that, I have to make the entire equation negative. So that means this will become a negative x, and this will become a positive 5. You know what? I'm going to rewrite these two equations over here so that you can see them better. This one says y equals 4x minus 5. That's just the original equation again. And then this one, when I changed it, became a negative y equals a negative x, and then plus a positive 5. Okay? Now I'm going to add those two equations together. Okay. And notice that when I add the y's together, y and negative y, really what happens is they cancel out. But since that's the only thing on this side of the equals, I need something to hold that space. So I'm going to say that that's equal to 0. 4x plus negative 1x would be 3x. And then negative 5 plus 5 also cancels out. That's just a coincidence. That doesn't always happen. Okay, it just so happens in this one that the 5's cancel out as well. And you could write plus 0 over here if you wanted to. Okay, now I'm going to divide both sides by 3. Don't let that 0 freak you out, by the way. That's okay that that's a 0 there. Still divide by 3 like you normally would. 0 divided by 3 is just 0, so I end up with 0 equals x. Okay. Now, just like before, I'm going to take that x coordinate and plug it into either one of my original equations, whichever one I think looks easier. This original equation, before I changed it all around, was just y equals x minus 5, so I think I'll put it in there. So y equals 0 minus 5, and 0 minus 5 is negative 5. Okay, sorry, that got a little close there. So that means my two coordinates are x equals 0 and y equals negative 5. So my ordered pair would be 0, negative 5. Oops, sorry, that's off the screen for you, isn't it? There we go. Sorry about all that paper twisting. So your final answer would be 0, negative 5 there. Okay? So this was an example of substitution. This was an example of elimination, but both methods work anytime you have a system of equations. Okay? All right, on to problem number 3. Now, problem 3, I have this parabola drawn in, and we talked in class about how this was an error of mine. I should have had this drawn in before I copied it for you. I gave you the coordinates today in class so that you could draw that in yourself. So if you didn't get that, probably the most important thing for you to know is that the coordinates of this point here are 3, 4. Okay? From there, we did write down these other coordinates in class today, but to be honest, they're not that important to the problem. So as long as you have that the vertex here is at 3, 4, we can answer this question. This is saying that this original parabola was y equals 2x squared, which means this parabola used to be right at the origin. Okay, but now we've picked it up and moved it over here. So now I want to know, what would the equation of this parabola be written in vertex form? Now I mentioned something a minute ago that we needed this vertex, that was the most important thing. That's because to get vertex form, you have to have the vertex. Okay? Here's what vertex form looks like. Okay? Vertex form, and this will also be on your formula sheet that you'll get to use on your exam. Y minus k equals a times x minus h squared. And here's why that vertex is so important. The letters for the vertex are always h and k. So we just found two of the numbers that we need to fill into this equation. We just need to take that 3 and 4 and drop them into place. So I'm going to put the 3 here for the h and the 4 here for the k. And the only other number we really need to fill in is this a. A always comes from your original parabola. Our original parabola here is y equals 2x squared. So our a value is 2. So now that I have those three numbers in place, I'm just going to bring down the rest of the equation. So this would be y minus 4 equals 2, and then parenthesis x minus 3 squared. And that's it. That's all the question's asking for us, for you to write this in vertex form. And there's your equation in vertex form. Y minus 4 equals 2 times the quantity x minus 3 squared. Okay. So now let's try the next one. The next one, this one also we sketched in class so that you had the picture in front of you. And again, if I'm looking for vertex form, the most important point is this vertex. The coordinates of this vertex are negative 2, 4, which again, remember, are your h and your k for that vertex form. Okay. So let's see if we can just write it left to right, the entire thing all the way through. Y just stays a y, minus your k value, which we said back here was 4, equals a. A isn't listed anywhere here for you. A is back in this original parabola, which it tells us that the original parabola was y equals negative 1/2 x squared. So that means my a value is negative 1/2. And then this would be x minus negative 2. Remember, when you subtract a negative, it's really like addition. So this would be x plus 2 squared. And that's it. You don't have to do anything else to it. It's just asking for it in vertex form. Y minus 4 equals negative 1/2 times the quantity x plus 2 squared. Okay, that's it for page 1 of your second review packet over chapters 5 and 6. Page 2 is coming right up.